finding angle measures using algebraic equations in 5 minutes. In this example, we have some angle measures that are given by algebraic expressions. All we need to do is decide which one of the 3 algebraic relationships we see in the drawing. Do we have supplementary angles, complementary angles, or equal angles? You'll notice that this acute angle is opposite of this acute angle, and they touch at the same vertex. These are a pair of vertical angles, and that means that they are equal. When we have equal angles, the setup is whatever information you have about the first angle is on the left side of the equal sign, and whatever information you have about the second angle is on the right. So the first angle is 8x plus 31, and the second angle is 16x minus 9. The equal sign will go in the middle. Now all we need to do is use our rules about solving equations using inverse operations to isolate our letter x. I think I'm going to subtract 8x from both sides so that I have a positive x on the right-hand side. Now I'm going to copy all of the terms that are left. Now I only have a constant term on the left, so I want to make this constant come over here and join it. This way I can combine like terms. Leaving me with 40 is equal to 8x. If I divide both sides by 8, then that means x is equal to 5. Let's take a look at another one. Again, I have a drawing, and all I need to do is determine which angle relationship we have. Do we have supplementary, complementary, or equal angles? And I can see here in the corner a perfect 90-degree box. That means I have a complementary relationship. The setup is the information from angle 1 plus the information from angle 2, then an equal sign and a 90, because complementary angles sum to 90 degrees. So angle 1 is 3x plus 11, angle 2 is 8x plus 2, and what I need to bring is that they sum to equal 90 degrees. So the blue information is given to me, and the red information I have to figure out myself. Now we're going to solve for x. This time, my x's are on the same side of the equal sign. So I'm not going to subtract, I'm going to combine. 3x plus 8x makes 11x. My constant 11 is on the same side as this constant 2, so I'm going to combine, giving me 13. Now, all I have to do is subtract 13 from both sides and rewrite what's left. Divide both sides by 11, and I get my final answer, that x is equal to 7. Let's try one more problem. This one looks busy, but we can still figure out the relationship. I have an obtuse angle here, and adjacent to it, I have this acute angle. And together, they make that perfect semicircle. And a semicircle means that we have supplementary angles. And in that relationship, the algebra from angle 1 plus the algebra from angle 2 will give us a sum of 180 degrees. We're going to combine like terms like we did before. Again, combine like terms like we did before. And now we solve for x. I'm going to add 2 to both sides and divide by 13. The answer is that x is equal to 14 degrees. Now sometimes you're asked to do more than find x. Sometimes you're actually asked to find each angle measure, meaning not how big is x, but how big is this entire angle, or how big is that entire angle. So this question is the same as the last one we did, right? So in the last problem, we've discovered that x was equal to 14. So if we know that x is equal to 14 by doing all of the work on the previous screen, then I can actually find the measure of angle SQR. I know which angle is SQR by tracing the letters S, then Q, and R. When I connect them in that order, I find the angle they're talking about. So the measure of SQR is 10x minus 22. So I'm going to erase and replace the letter x with a 14. Use your calculator to compute. 140 minus 22 is 118. Now I can find the measure of RQT. If I trace from R to Q to T, I realize it's this angle here, called 3x plus 20. Again, you erase and replace the x with the value you found before, which is 14. Use a calculator if you need help to computing. 42 plus 20 is 62. Now, we knew these angles were supplementary, so let's check our math. Is 118 plus 62 equal to 180? We hope so. And they are. So that's how we know we did it right. And that's how you use algebraic equations to find angle measures.